Welcome to the Configure Price Quote Podcast. My name is Frank Sohn and I'm the founder of CPQ Consulting. This podcast is 100% focused on Configure Price Quote, also known as CPQ, and will provide you useful insights into this topic. My guest today is Sanjay Mittal, founder of Predictica AI. Sanjay is an AI technologist, entrepreneur, and business executive with a long history in artificial intelligence, constrained reasoning, conversational AI, and enterprise decision systems. His background includes work at Xerox PARC, founding Selectica, an early pioneer in internet sales and configuration solutions, and later co-founding SpotSot, a mobile retail offer platform. Sanjay holds a PhD in computer science with a specialization in AI, a BTech in electrical engineering from IIT Kanpur, and multiple patents in conversational AI, machine learning configuration, and mobile technologies. Today, we will talk about Sanjay's work at Predictica.ai, especially the idea that large language models are strong at language, but not always reliable at following business logic. Predictica's recent white paper argues that many enterprise AI risks are not only factual hallucinations, but also logic hallucinations, where an AI system may reference the right information, but apply rules, constraints, policies, or exceptions incorrectly. We will also discuss what this means for CPQ, product configuration, pricing, quoting, and AI agents in enterprise software. Super excited to have Sanjay as a guest today. Sanjay, welcome to the CPQ podcast.
Thank you, Frank, for inviting me. I'm very excited to be here. I've heard a lot about the podcast series that you've been doing. So it's really an honor and privilege to be here.
Same here. Very excited to have you now. And I think it's a very timely topic, AI, right? So, and you have worked a long time in it, including, as I mentioned in the introduction, your time at Xerox PARC, and you work as an entrepreneur. Now, I was wondering, what did originally attract you to artificial intelligence, and has your view of AI changed over the years? Because you have been involved in AI for decades.
Sure. I mean, I got interested in AI because as an undergraduate in India, even though I was a student in electrical engineering, I really got attracted to software and I started programming on my own. We didn't have computer science as undergraduate at that time. But as I programmed, I started reading books, and AI had been defined about 20 years prior to that in 1956 by John McCarthy, for those who might know the history. But right from the beginning, people who were in software and computer science were kind of intrigued by the idea of, can we get the computers to do more than just the basic stuff that they were doing? And the canonical example was human beings with our ability to reason and think and see and talk and et cetera, et cetera. So I got attracted to AI right from the beginning. And when I applied for grad school, I ended up going to Ohio State. It was one of the schools that offered me a scholarship. And my future professor and guide, Professor Chandrasekharan, was already starting to get a name as kind of a iconoclastic thinker in AI, and it was a privilege to work under him and get my PhD.
Excellent. My next question is about something that our common friend Rob Milks mentioned, right? So you were at Selectica, an early internet-based sales configuration and constraint reasoning solution, right? So, and I was wondering, when you look back, what did that experience teach you about product configuration, enterprise selling, and also the limits of automation?
So I was not just at Selectica, I was actually the founder. I started the company partly based on the work I'd done at Xerox PARC. I published pretty extensively on constraint-based approaches to configuration. And just to give you a little bit more history on product configuration, one of the early applications for AI way back in 1979, which was probably the first big commercial boom in AI, was actually caused by Carnegie Mellon and DEC solving the configuration problem. And that led people to think, oh, if you can solve configuration problem, then this whole symbolic AI rule-based systems actually have a future. And so after my PhD, as I started working at Xerox PARC in research, I realized that the paradigm at that time, which is you write lots and lots of rules, is actually not sustainable. It's very hard to maintain. It's very hard to write. And so I started searching for a different way of doing things. And that led me to constraint-based approach where we're trying to look at what the relationships are between the entities and the components that are involved in configuring. And if you could directly reason with those constraints, the constraints are compact, they're easy to maintain, so I leveraged that work to start Selectica. I think the thing that I find quite interesting in retrospect is that despite having a very strong research grounding, I had papers, I'd built multiple systems at Park. It still took, I would say, maybe well over 100 man years to go from that initial work to something that we could deploy at major enterprises like Cisco or Dell or later on IBM and GE. So the path from basic research to full commercial deployment is still a very, very long path that people often don't realize. I think the other thing about product configuration is that uh, I mean I'm very proud of the fact that let's say a customer like Cisco, where we went live in 2000, actually continued to use our software for the next 15 years till 2015, during which period their revenue increased by a factor of five. I think that says something about, I think, the quality of the team we had and the work we had done uh, to build all of that process and automation and everything. I don't know what I can say about limits of automation. I think we had a pretty automated system for our customers in those days.
Excellent. Yeah, and I know Cisco as well as HP and others were very well known pretty early on, right, for a lot of the work with product configurators and so on. But now what I'm wondering is you have worked across research, the startups as mentioned, right? So you have patents, product development, worked a lot also with enterprise customers. I was wondering what part of that journey shaped you the most as a technologist and founder?
I think since I've kind of spanned the whole spectrum from doing basic research all the way to building a company, building the product, taking it to customers, and at Selectica especially, and even currently at Predictica and in between, I've been very, very customer focused. I mean, my kind of entire DNA has been around how do you make sure the customers are successful. You listen to the customer. You don't always actually build strictly what they want, but you build what they think they need, but it gets modified by, when the rubber meets the road. So I think I've gotten a very good appreciation for uh, what it takes to actually get something deployed and running for large demanding enterprises. And it's very hard for me to imagine customers more demanding than Cisco or IBM or GE, some of the largest companies in the world, both in terms of the product diversity and their, very, very complex internal processes that we had to fit into.
Excellent. And you're coming at the right time to the CPQ podcast, at least, right? So, because this excitement about AI has been almost all consuming for the last 2.5 years, right? And I was wondering, when you look at today's AI excitement, what do you think people are underestimating or overestimating or just misunderstanding? What's your point of view on that?
So let me step back a little bit about how AI has changed from my time then to now. Um, when we started Selectica in 96 and before that in my research, the knowledge bases were still pretty much built by hand by team of very sophisticated engineers. It might be easier to maintain than rule-based systems, but it's still non-trivial. The promise of AI today with Gen AI and deep learning behind that is that you can somehow just dump all the documents and corporate information, and the Gen AI system will kind of automatically figure everything out and give you the right answer. And I think that is where my current work is also focused on, because it's become very clear that the Gen AI systems, powerful as they are also very brittle, and they hallucinate, which is really a kind of anthropomorphic term for non-determinism. They're essentially non-deterministic problem solvers. What that means is that you're not guaranteed to get the same answer from run to run, which actually can be very disconcerting. So I think the thing that people are completely underestimating about today's very powerful Gen AI systems is that powerful as they are, they're also very brittle and non-deterministic. And if you don't know how to deal with that, it's going to go down, you know, lead to very bad results.
Mm. And we will talk more about that in a minute. But before we do that, I was wondering, Sanjay, what do you like to do when you don't work? I think I hope you still have some time where you don't work. What do you like to do then?
I have a group of friends that we hike. I mean, I live up in the mountains in on the East Bay in Silicon Valley in a town called Fremont. I live just below a very popular hiking place called Mission Peak. So we like to go hiking. I do, fair bit of hike. I just did a pretty arduous hike to Nevada Falls in Yosemite. We do that annually. I like to play cards. I have some friends that we play kind of fun poker, but I also like to go to Vegas and kind of play tournaments there. I think that's, and
Oh
we like to
wow!
travel.
So you play real tournaments, so where you play against professionals, half professionals, or is that amateur
I've
competition?
not played a World Series of poker style tournaments,
Uh-huh.
but I like to go to Vegas and just kind of, they have tournaments running in all the casinos all the time. So I like to kind of find low end entry fee tournaments and play there. And sometimes I win, most often I don't, but it's fun to do that.
Very cool. I think that's the first time I heard that here on the podcast. Very cool. So now let's switch gears a little bit and let's talk about Predictica, right? So I would like to understand a little bit better what products and services Predictica offers. Can you tell us a little bit more about that, please?
Sure. So Politica originally started out as a conversational AI platform pre ChatGPT, right?
Mm.
Our goal was, you know, few years back, we realized that the whole world is moving towards trying to be more conversational instead of having scripted, apps and websites. So let people describe in natural language what they want, and we can have AI agents that would automatically just understand the intent and the entities in the conversation and make sense, and that can be applied for customer service, for sales, food ordering, insurance. I mean, you name the whole gamut of applications. And so we had built our own backend engine, which turned out to be basically just like Selectica 2.0 in that it was a very, very powerful, or it is a very powerful constraint-based reasoning engine. But we initially were using it more to drive conversations, and we had built our own natural language understanding front end. When ChatGPT came along, we realized that our natural language understanding was obviously not at the same caliber, and trying to support conversational application directly was probably not the right market opportunity. And as we played with the frontier models, especially the OpenAI, Gemini, and Claude, we realized that hallucination is emerging as a really, really serious problem. And we basically started using our a backend constraint engine as a deterministic co-pilot. Basically, let the LLM propose something and let the deterministic engine verify that, and if it finds a mistake, it can reprompt the LLM to go fix it. We did some early work with some simple puzzles like river crossing puzzle, where we found that if we use exactly the puzzle that's been published in the literature, the LLMs are doing a good job. Then we create two or three variants that have never been published. I mean, I created the variants, and we found that all the LLMs pretty much failed. I mean, we did, and we have published white papers that are publicly available. Then we went on to look at business problems like EU 261, which is the EU regulation for compensation for flight delays and cancellation and so on. And we showed the same thing. And now when we come to CPQ, we find that the same metaphor works just as well. Let the user interact with the LLM, let the LLM propose a solution, and let that solution be passed over to our engine that can validate that. And if it finds a mistake, it reprompts the LLM, it goes back and revises the answer. So the user ultimately gets the right answer.
Excellent. Now I have a couple of questions about the white paper, but before I ask you the question, I want to make sure that our listeners have a chance to catch up on that as well. Please tell me first the title of your white paper and where interested listeners can find the white paper. We will, by the way, also have the link in the show notes for that.
There are multiple white papers, so I don't want to give you any particular name. My company's website is uh, https://www.predictica.ai, and if you go to the assets part, you'll see a bunch of white papers. The first one is where is the AGI if the LLM cannot cross the river. The second is guiding the LLM, and so on. So I would just encourage people to find the white papers and read them. Or if you have specific questions, send me an email, sanjay@predictica.com, and I'll be happy to point you to the right paper, have a discussion with you. Uh,
Perfect. Got it, got it. So the last one that I had to look at, right? So there was at least the white paper. where I was wondering, you made a distinction between factual hallucinations and logic hallucinations, and I was wondering if you can explain the difference in simple terms a little bit to myself and to our audience.
Right. So when the LLMs first came out, the first thing that people noticed is that, look, LLMs have been trained on some large amount of corpus that was scraped from the internet, but they may not know things that are very specific to an enterprise. So specifically, if you're working for some corporation and the corporation has some specific data about employees or products or price or features, the training corpus of the LLM would not have that. So if you ask it a question, it'll probably make up the answer and it'll get the quote unquote hallucinated answer. And the way to fix that is what something called RAG, which stands for retrieval augmented generation. And the basic idea is before you ask the question, you feed it the documents as part of the context of the LLM, so that when you ask the question, it can look at the content that you've given it, and if it has the right answer there, it'll give you the answer from there without resorting to its own internally trained corpus. So that takes care of a lot of the fact kind of questions. What it does not take care of is if the answer is not directly there, but it requires reasoning through that. It's like there's a fact A there, and there's some rule someplace, and then you have to take the fact, apply it over the rule, deduce something else, and then use it to apply to another rule. And the chain of reasoning is basically what is called, and now of course over the last year or 2 years, seeing more and more reasoning models. So the reasoning models basically, when they fail, that failure is what we call logic hallucination. They actually have the rules, they have the facts, but they are not able to consistently apply the rules to derive the right conclusion. Basically, they're failing at the real inference. The problem is the LLM world has repurposed the word inference to simply mean the prediction of the next token. But that to me is the least interesting inference. The more interesting inference is really in the logical sense, where you have fact A and your rule A implies B, and you make an inference that B is true. Those are the kind of inferences that the LLM basically is failing to do on a reliable, consistent basis.
If your company is evaluating CPQ and you're not sure which vendors are actually worth your time, try the free Novo CPQ Briefing Match app. You answer a few questions about your business and requirements, and it gives you a more focused starting shortlist of relevant CPQ solutions. It's meant to save time, reduce noise, and make early CPQ research a lot easier. Go to novocpq.com and click on the CPQ Podcast page to find it. And in one of your white papers, you argue that hallucinations in business applications are structural, not accidental, because probabilistic language models are being asked to perform deterministic logic enforcement. Can you explain what you mean by that?
Well, so we don't need to go into the theory of the LLM, but it's basically a deep neural network where the weights have been calculated that kind of predict, given n tokens or n words, what is the next likely n plus one word that will be there in the sequence, based on millions and billions and trillions of documents of words that have been fed in building the deep network. So the network itself is basically a series of weights that relates one word to another word and so on. On top of that, there is something called the transformer architecture, which takes n words and uses that to predict an n plus one, and then it feeds it back in. And so that's how the answers get generated. And the transformer inherently is not deterministic. It does not always take the same path in coming up with the answer. So if you ask the same question 5 times, it's quite likely you'll get 5 different answers. And that means that if the quality of the answer is important to you and you really need to get very, very high accuracy, you'll be disappointed.
Excellent and fascinating to listen to your explanations. It really makes sense. So now I was wondering, right now, a lot of the CPQ vendors, right, and more beyond that, there's also enterprise software vendors, but I focus on the CPQ vendors, right? So they're talking about AI agents right now. In your view, where are large language model-based agents useful today, and where do they still need some guardrails, in your opinion?
So let's first start by looking at the accuracy requirement for CPQ. right? CPQ basically means that here's a company that is selling a bunch of products. Let's stick to products. I mean, it could be services. But at Selectica, we had customers both on the hard goods, the Cisco's and the Dells and the IBMs and GE. But we also have the services companies. We had Disney as a major customer. We had AT&T for both their, telephone plans. We had health insurance companies selling health plans, which of course were soft goods. But it doesn't matter. Conceptually, they're all entities with relationships. And what the CPQ or the configurator is doing is making sure that it produces what we call a correct and complete answer. Correct because every rule and every constraint that is there has been checked and verified and applied. And complete means that everything that is needed to comprise the answer is there. So, if you're ordering a PC and you don't have memory, that's an incomplete solution, right? If you order a bike and one of the pedals is missing, that's an incomplete solution, right? On the other hand, if there are constraints about, how much torque can be supported by the pedal to drive the wheel, and that constraint is not satisfied, then you get underpowered bike, and that means that you have incorrect configuration. So the requirement for a CPQ system is that it has to produce a correct and complete configuration, and it cannot be like 95% right. You can't say, well, I'll give you a computer system that 100 ones that deliver 95 will have the right memory, but 5 of them will have the wrong memory. No, that's not good enough. I mean, at Selectica, we used to guarantee that every single constraint that has been modeled in a system will be reliably checked 100% of the time. We actually guaranteed 100% correctness. It was not 99, it was not 99.5, it was 100%. To the extent that the companies, whatever the customer gave us, as long as they gave us all the right information, we would model it for 100% correctness. And that is the requirement still stays today. Now, when you take that requirement of 100% correctness and you bolt it onto an LLM that is inherently less than 100%, you have a mismatch. So the only way you're going to get that right is by you have to have a deterministic co-pilot sitting next to your LLM that will take the LLM's output and give you that 100% guarantee and say, okay, you're proposing something, I'm going to double check it, and maybe the LLM will do a good job, 60, 80, 90%, maybe 95%, but the other 5% is crucial because that 5% means that you have dissatisfied customers, you have revenue leak, et cetera, and none of that is acceptable.
And which of these risks are most likely for CPQ customers, right? So that they encounter these issues. Product configurator, you already mentioned pricing, I think. Anything else that
Well, pricing is one, right? I mean, if you apply the wrong pricing rules, you end up giving too much discount.
Yep.
That's bad for the company. If you give too little discount and the customer ends up finding out later on, they might say, wait a minute, we had a most preferred agreement and it didn't do it, and that can open you to lawsuit. So, applying the wrong pricing and discounting rules can be detrimental on either side of that equation. Same thing with product. I mean, if you pick incompatible parts that don't work together, or you use parts that are no longer being manufactured, that's a problem. I think as you're starting to build more and more complex system, and we have been working with like full data center configuration. You've got servers into racks, into rows, into halls, into data centers. The power requirements start to become a major global requirement, right? I mean, you have to look at the power starting at each CPU, all the rack, all the way up to the server, then to the racks, to the rows, and so on. And so all those global constraints have to be satisfied, in terms of power and heating and cooling and all that kind of stuff. So anyone trying to build a correct and complete solution has to take all of that into account, and mistakes in any of those things is very hazardous.
Got it. And do you see Predictica in this case as replacing existing CPQ configuration engines or as an additional validation layer around AI-driven CPQ experiences?
So two different things. I mean, we can actually work with existing configurator engines, provided they're providing any real value. But I suspect the real architecture is going to be there's an LLM on the front end that the customer interacts with. The LLM understands what the user wants, extracts all the information, puts together a partial solution, hands it over to us. We validate that, either find errors, or we might say, hey, that's good, but if you're going to do this, you also need X, Y, Z, and we can suggest that back. And then the LLM continues, goes back to the user. And so we expect us to be kind of sitting alongside the LLM in a very cooperative mode and collectively help to find the right answer for the customer.
Got it. And I see one concern with the customers that I work with right now is also auditability, right? So, for example, if an AI agent recommends a configuration or price, decision makers want to know why, right? So, and how does deterministic validation help with this explainability?
So the nice thing about determinism as it means is it is deterministic. I mean, if you give it n inputs, you will get exactly the same thing happening every time, right? That's what determinism means. It's not like, one time I'll go this way and one time I'll go that way. And so you have no idea if you run it 10 times what the output will be. So deterministic means there is a deterministic path, right? There's a same path every time for the same sequence of input. Now, if you change the input order, obviously the behavior will be different. So in terms of auditability, what that means is that to the extent we have the underlying rules and constraints and relationships explicitly modeled, we can actually give an account at the end of all the ones that ran, if any failed, and even possibly the ones that never got tried because they didn't have the relevant information. We can actually give a very, very detailed accounting to the extent that is needed. And so, for example, in the EU 261 bot that is actually publicly available, you'll find the link on our website. You can go in and describe your flight and say, hey, I flew from San Francisco to Milan via Amsterdam. The first segment was on KLM and the second was on Lufthansa. And my first flight was on time and the second was delayed by 4 hours. Can I get any compensation? It'll actually, you'll see the LLM produce some output, and if it makes a mistake, regardless, it'll turn to a deterministic model, and it'll actually go through and give you the right answer, and also an explanation of what EU 261 rules actually applied in calculating that answer, both in terms of eligibility and whether any compensation is due and the amount. And so at the end, you not only have the right answer, but you also have an explanation of why that answer is the right answer.
Excellent. And what would your advice be to enterprise customers evaluating AI capabilities in CPQ solutions? What questions should they ask vendors before trusting an AI-assisted quoting process?
Well, I think the question they should be asking is, how are the vendors guaranteeing the correctness and completeness? It's not just correctness. And correctness and completeness are two important markers. Correctness means everything that has to be checked has been checked and validated. Completeness is almost equally important because you cannot deliver a system where some shell parts are missing. So completeness, without completeness, you really don't have a good CPQ solution. So the first question the enterprise customer should be asking their vendors is, do they actually even have a notion of correctness and completeness? If not, then you probably either your product is so simple that it doesn't matter, or you're talking to a vendor that cannot guarantee you that.
Excellent. And now I'm asking you a little bit to play the role of an oracle, right? So when you look forward, so 1-2 years, what do you think? How will AI agents change CPQ, and where do you think the industry should be careful?
So I want to focus on the LLM, which underlies the AI agent, right? Because AI agent, in some sense, is a layer on top of the LLM, but they're relying on the underlying capability of the frontier models, whether it is built by OpenAI, Anthropic, or Google, or they are going to start relying on some of the new Chinese models. So let's just call them LLM collectively, right?
Yeah.
I think the bet that everyone is making is that at some point down the line, maybe not so far in the future, the LLMs will somehow become what is called AGI, artificial general intelligence capable, which means that you can throw any problem at an LLM and it can solve it at the level of, a decently smart human being for any problem, right? If it ever gets to that point, then of course, all bets are off, because that means that most of the stuff that we are trying to do outside of the LLM is not needed. You have an LLM that can do everything. I personally don't think that's going to happen, because even if you look at the human specialties, there is no single human being that currently, other than maybe God, who's not a human being, who can claim to be infallible. So if human beings are not infallible, what makes us think that LLM would ever be infallible? And if LLMs are not infallible, then a lot of the work that has gone on before and will keep on going in terms of QA and testing and determinism and so on are equally relevant. So looking forward towards the future, I think it's safe to assume that the LLMs will get more powerful. At the same time, there'll always be mistakes they'll make. Small or large doesn't matter, because if you want close to 100%, even 2% error is not good enough. So I think determinism as a co-pilot to an LLM is going to be critical. Otherwise, people are not going to be able to build truly autonomous AI agents.
Fascinating, Sanjay. I could listen to you for hours and we could keep going. Unfortunately, we're coming to the end of this episode, but I'm pretty sure we will have some interested listeners. They want to know more about Predictica, what you do, how you could potentially collaborate with CPQ solutions. So what's a good way for them to contact you if they have any follow-up questions?
So I think I already mentioned, feel free to reach out to my email, sanjay@predictica.com, predict, IK as one word, .com. You can also go to our company's website, www.predictica.ai, and you'll find a lot of resources. And I'm happy to engage. You can also reach out to me on LinkedIn. Just search for Sanjay Mittal Predictica or Sanjay Mittal Selectica. You'll find me. If you mention that you heard me on Frank's podcast, I'll be happy to connect with you.
Sanjay, thank you very much for making time for the CPQ podcast today. And by the way, we will have all the information that you mentioned in the show notes. So anyone who wants to contact you should look there if they didn't catch your notes. Thank you very much again, Sanjay.
Thank you, Frank.
I'd like to thank everyone for listening and hope you learned something interesting today. If you like the podcast, please go ahead and rate it on iTunes or share it with your friends and colleagues. In the meantime, you can find us online at www.novocpq.com. So long, everyone.